By the end of this segment, you will understand the principles of how we go about naming organic molecules, in particular, how we go about naming alkanes. And remember that alkanes are molecules that have just carbon-carbon single bonds, and they don't have any heteroatoms in them. So they have no non-carbon, non-hydrogen atoms in them. For example, the yellow skeletal formula that is shown on the first slide here is an example of a skeletal formula for an alkane. So by the end of this segment, you will know how to name this alkane as well as any other alkane that might come your way. The nomenclature of all of the other types of functional groups is built upon the nomenclature that we're going to use for alkanes. And so it's really important to get a solid grasp on this information now, because you are going to over and over and over again be seeing various concepts related to naming organic molecules. And this is the foundation for all of that. So if you look on the web page, you can download a file that gives you what I call the Quickstart Guide to Alkane Nomenclature. And here's the first part of that one-page sheet for the Quickstart Guide to Nomenclature. So what we're going to do is walk through this sheet step by step, and then we're going to apply these guidelines toward actually naming some organic molecules as examples to highlight this. So we're going to, in fact, take this sheet and we're going to draw out an organic molecule, and we will go through the process of naming that molecule as we look at this sheet here. So our example problem that we're going to use to get started here with naming organic molecules is we'll go ahead and make this structure that we're looking at right here. So for this particular structure, we're going to go step by step here through our nomenclature guide. And step one is find the longest continuous carbon chain. And that longest continuous carbon chain is going to determine what we refer to as the parent name. So just as typically people take at birth the last name of one of their parents, molecules do the same. The parent name is defined as the name that corresponds to the longest carbon chain. And those different possibilities for parent name are listed here, starting with a longest carbon chain of 1 carbon, having the parent name methane, all the way up to 10 carbons, having the parent name decane. Yes, there can be carbon chains longer than 10 carbons, but you're only responsible for knowing by heart these names corresponding to 1 to 10 carbons. So you are expected to know by heart this information about number of carbons in the chain, because you will be seeing that over and over again as you go through the process of learning names of organic molecules. So let's go ahead and take care of step one here of our nomenclature guide for this example problem that we're getting started with here. So we find the longest carbon chain, and that's the longest chain that we can trace out from one end of the molecule to the other. It can be going vertical, horizontal, however you want. It's just the main thing is that it has to be the longest chain in the molecule that you can get through without lifting your pencil or without having to backtrack. So you start at any end of the molecule, at any end of the line, and follow through to figure out where the longest carbon chain is. So to find the longest carbon chain, we could start right here at the far left if we want, trace through in red, and I'm following at every point the longest pathway that I can through the molecule. If we tried any other pathway, we would have had a lower number of carbons. So let's count how many carbons we have in this particular chain. So remember that a carbon is represented by each bend in the line and each end of the line. It'd be a good time to pause, count the number of carbons, and then hit resume to find out how many I came up with and make sure you get the same number. So I come up with there being 8 carbon atoms in this longest carbon chain. So 8 carbon atoms in the longest carbon chain is going to make this molecule fit the name octane as the last name, as the parent name. So I'm going to go ahead and write that in red to match the color that I highlighted the parent chain with. So now that we've accounted for those 8 carbons of the parent chain, that is it. Everything in red in the structure has been accounted for. Now what we need to do is we need to look at accounting for those groups in black that we haven't already accounted for in the name. So what we're going to do in order to identify those branches, as we call them, branches are what branch off of the longest carbon chain, is we're going to come up with a systematic way of numbering that parent chain, the chain that we've shown in red, and we're then going to assign a location based on that numbering to each of those black branches coming off of the chain, and we are also going to name those branches that are coming off of the chain. So we both have to name the branch In other words, identify what it is, and we also have to identify where the branch is, because the branch could be at different spots along the chain. And if it's at different spots, that would mean that you have created different constitutional isomers. And in the case of naming, we want to be sure that a single name corresponds to a single molecule, that there is no ambiguity about exactly what constitutional isomer you're referring to, because different constitutional isomers will have very different properties in terms of their biological effects, in terms of their commercial applicability, et cetera, et cetera. So we need to be confident that we're referring to exactly the right molecule every time. So we found the longest carbon chain in step 1. Now what we're going to do is, in step 2, number the parent chain beginning at the end of the chain that is closer to a branch. So we'll go to number this chain at the end closer to where a branch comes off. Remember, our branches are in black. Those are the parts of the molecule that we haven't accounted for in our longest carbon chain. So starting from the left end, that would mean that the first branch comes off at carbon number 2. If we started numbering from the other end of the chain, 1, 2, 3, the first branch would start coming off at carbon number 3 of the chain. And that's not the way we want to go with this, because putting a branch at carbon number 3 is inferior to putting the branch at carbon number 2, because we want to start numbering the carbon chain beginning at the end closer to a branch. So let's go ahead and finish numbering this chain. Each carbon of the chain will have a number. We should end up with 8 in total. If not, that means that we have done something wrong in counting or numbering along the way, because we already ascribed the parent name octane. So we did indeed come up with 8 carbons there in our longest carbon chain, and we started numbering that always from the end closer to where a branch comes off. So that was what we did there. And then step 3, what we need to do is list the numerical locations, where the numerical locations are defined as what we just listed in green there, the spots along the parent chain where each branch comes off. And we describe these branches as alkyl branches, because alkyl branches are defined as carbon chains, and those can be branched chains as well. And specifically, they're going to be carbon chains of sp3 carbons, meaning alkane carbons. And that's why they're called alkyl groups. When a carbon chain is not part of the parent chain there in red, but instead is branching off, we refer to it as an alkyl group. Alkyl group is a term that's going to come up a lot in organic chemistry, so that's really good to commit to memory. All right, so we're going to list the numerical locations and the names of the alkyl branches. We're going to list those in alphabetical order before that parent name alkane that we have listed there. So going through and doing this, we're going to keep these guidelines in mind here that are under bullet point number 3. So looking at the branches that we have coming off of the main chain, we can name branches that are linear, listed down here, as just the name of the corresponding alkane length with the ane suffix replaced with YL. So for example, a methyl branch is a 1-carbon branch, just as methane up top would be a 1-carbon chain. Ethyl, 2 carbons of a branch, propyl, 3 carbons, et cetera, et cetera. And this is only the case for linear branches. A linear branch meaning there's no branches coming off of that branch. It's just a straight chain coming off of the molecule. So in the case of our compound, we do have 2 linear branches that are coming off of the compound. Those are right here in blue, and also over here in blue as well. And both of those are methyl branches because they both have 1 carbon. Remember, when we count the carbons of the branch, we're not counting the carbons in red because we already counted those as part of the longest carbon chain. We're only going to count each atom or each group 1 time here. So we have 2 methyl branches coming off. And then we also have what I'll highlight in yellow here. We also have an additional group coming off, or branch coming off of our parent chain. And this one's a little more complicated because it's not a straight chain. Instead, when we come away from the parent chain, we reach a point where we split. This 1 carbon there in the middle is bonded to 2 different methyl groups. So we need a way to go about naming that. And that way that we go about naming that is by using the guidelines here for so-called nonlinear branches. So nonlinear branches are often identified using the common terminology that is listed here on your handout. And these are definitely names that you want to get down by heart because you're really commonly going to be using those to describe molecules. And the squiggly line in each of those, so the squiggly line there, there, and there, indicates the parent chain. That indicates the longest carbon chain that this is connected to. So what we're focusing on is what matches the pattern that we see in our structure. And what matches the pattern that we see in our structure is that group there on the lower left, the isopropyl group. So we could describe this as an isopropyl group. And this term comes about because the group in total has 3 carbons. Remember, we're just looking at the 3 carbon atoms of the branch itself, not at the parent chain at all. So we have 3 carbon atoms, dot, 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 in blue to represent that. And the term propyl means there's 3 carbons in total in that branch. The term iso means that at the next to the last carbon of the chain, there's a methyl branch coming off. So when we look just within this group, if we have the longest carbon chain, that would be 2 carbons right here. At the next to the last one of those, right here, we have a methyl group coming off. So that's why we refer to that as an iso group. And the same thing is going to be true if you look down here. That's our isopropyl group had this 2 carbon chain within the group. At the next to the last one, you have a methyl branch here going down the chain. This right over here would be your parent chain. Coming down, you have CH2, CH, CH3, and at that next to the last carbon of the chain, you have a methyl branch coming off. And again, so that's referred to as an iso. In this case, it's isobutyl because it has 4 carbons in total in this group. The next one is called Sach Butyl because the methyl group is not coming off at the next to the last carbon of the chain. Instead, it's coming off at the very first carbon of the chain. And then tert-butyl is described as such because it has 2 methyl groups coming off at the next to the last carbon of the chain, and this would be referred to as a tertiary carbon because it has 4 other carbons directly bonded to it. So that's why we call that a tert-butyl group. Isopentyl, 5 carbons in total in this group. Next to the last one has that methyl branch coming off, and that's why we refer to this as an iso group. So you are expected to know all of these different groups by heart and be able to apply them toward names. In addition to referring to these by their so-called common names, such as isopropyl, isobutyl, etc., you can also alternatively refer to them by a systematic name for the branch, which are these names here that I'm highlighting in green. And just like any branch name, they end in the suffix YL to indicate their branches. Just like up here are linear branches, we're ending in YL for ethyl, methyl, propyl, etc. And here, when we look at these terms to describe the branch, what we're doing is we're counting the carbon atoms within the branch to find the longest carbon chain in that branch by itself. So our longest carbon chain in this branch, starting from where it comes off from the main molecule, that squiggly line would be 1, 2. So we describe this as an ethyl group. And then at position number 1 of that ethyl group, there's a methyl group coming off, so we call it 1-methyl-ethyl. On the isobutyl group, a synonym for that is 2-methyl-propyl, because we can number the longest carbon chain of that group. So we're looking just within that group by itself. We number it 1, 2, 3, starting from the carbon that's just separated from the parent chain there is the squiggly line. So we have 3 carbons in total. And so therefore it's referred to as a propyl group in that systematic name, and at carbon number 2 there's a methyl group coming off. We could come over here to our neopentyl group at the far right, and our neopentyl group, squiggly line again, represents the parent chain. We start numbering from the first carbon away from that, carbon 1, carbon 2, looking for the longest carbon chain, leads us here as carbon 3. And we refer to that as a 2,2-dimethylpropyl group because our longest carbon chain that we mapped out there has 3 carbons. And at carbon number 2, there's 2 methyl groups coming off of that we haven't accounted for already. So therefore 2,2-dimethyl. And the 2,2 indicates where those methyl groups are located. Where having 2 2s in there indicates there's 2 methyl groups at the same carbon atom. So with that information in mind, we can go in and refer to our group here in our example molecule as either an isopropyl group or we could alternatively refer to that isopropyl branch instead as a 1-methyl ethyl. Either is totally sufficient in naming this molecule. So 1-methyl ethyl. And now what we're going to do is, using the guidelines listed back in step number 3, we're going to go ahead and fill out the complete name for the molecule. So the parent name for the molecule is going to be octane, like we said. That's going to be at the very end of the name. I'm going to rewrite that name down here so they have a little more space. So octane is the parent name. Then we go from there with naming the alkyl branches. When we list the names of the alkyl branches in the molecule, those are going to come before the parent name, octane. And we're going to list those in alphabetical order in the name of the molecule. So listing them in alphabetical order, we are going to be sure to not include terms like di, tri, etc. that indicate how many of that particular branch there are. We are going to consider terms like iso, etc. in determining the alphabetical order. We'll know they're alkyl branches because they'll all end in the suffix YL. So when we plug these in, we're also going to use dashes to separate numbers from letters in the name. We don't put any spaces in between numbers, letters, anything. It's just going to be a hyphenated string of words and numbers here. So octane is the parent name. We're going to go ahead and use these criteria for step 3 to fill in the rest of this. So we have 2 methyl groups. So we'd refer to those 2 methyl groups as being a dimethyl. And remember, when alphabetizing that, we consider just the M from methyl, not the D from di. And then we also have an isopropyl group or a 1-methyl ethyl group. So there are 2 possible names for this molecule corresponding using isopropyl or 1-methyl ethyl. Let's use isopropyl first. And the isopropyl comes earlier in the alphabet than methyl. So we're going to put isopropyl first in the name as well. So we'll do isopropyl. And we always need to specify where that isopropyl group is located in the molecule. It's at carbon number 5 of the parent name, parent chain. So we'll list it as 5-isopropyl because it's coming off here at carbon number 5 of our longest carbon chain in red. And then from there, after we've called that 5-isopropyl, and remember we use a dash always to separate letters from numbers, and there's no spaces involved in this, just a dash, so 5-isopropyl. And then next up is going to be our 2 methyl groups, or also known as our dimethyl group, and so we have to put a dash after isopropyl because we're going to next fill in those 2 methyl groups and indicate their physical location in the molecule. So those methyl groups come off of carbon number 2 and carbon number 6 of the parent chain, so we call that 2,6 dimethyl octane. And yes, it is correct that the term dimethyl runs right into octane, no spaces between those 2 terms. So we need to make sure that we've accounted for every feature of this molecule. So we've accounted for, meaning every atom of this molecule, we've accounted for in the name all 8 of the carbons in the longest carbon chain was accounted for in the name octane. So we got that taken care of. 2,6-dimethyl accounts for the methyl branch here and the methyl branch here located at carbon 2 and carbon 6. And then carbon number 5 is where we have the isopropyl group coming off, and we've accounted for that as 5-isopropyl. So with that, I've highlighted every single atom in the structure and corresponded that to some portion of the name here, indicating to us that we have identified every atom and its location. The numbers here are indicating the location of each individual branch within that longest carbon chain. And we always are using dashes to separate letters from numbers. And we haven't put any spaces whatsoever in the name. So with that, let's go on and go about naming this using the term 1-methyl ethyl to describe the isopropyl branch, because those 2 terms, isopropyl and 1-methyl ethyl, are synonyms of one another. The only thing that may impact is how we go about alphabetizing the name of the molecule. So we'll go ahead and fill in octane because the parent name of the molecule is not going to change. So we'll go ahead and fill in octane in red, just keeping with a theme from earlier. And then we have our 2,6-dimethyl group and our 1-methyl ethyl group. So you have to think about which one of those we're going to put first in the alphabet, and the methyl is going to come before 1-methyl ethyl within the alphabet. So we'll go ahead and fill in first in this name our 1-methyl ethyl group, and then we'll first fill in our dimethyl group, and then we'll fill in our 1-methyl ethyl group. So first off in the name, 2, 6-dimethyl, because methyl comes before methyl ethyl in the alphabet. And then using that term 1-methyl ethyl, here's the trick for that. So we want to be sure that we're not ambiguous about the fact that that number 1 in the term 1-methyl ethyl is referring just to the atoms that are in that branch, not to the whole long parent chain. And so what we do is in the name, to refer to a situation where we have a number within a branch, we put that in parentheses. So we do 1-methyl ethyl with all of that in a parenthesis to indicate to us that the 1-methyl ethyl group is all a branch, that is not some weird branch coming off of carbon number 1 of the longest carbon chain or something like that. Instead, when it's in parentheses, that means that we have a branch that is an ethyl branch, and at position 1 of that 2-carbon branch, we have a methyl group coming off of it. So put all that in parentheses, and then we still need to specify that that 1-methyl ethyl branch is coming off at carbon number 5 of the longest carbon chain. So in order to specify that, what we do is immediately prior to that 1-methyl ethyl, we put a dash, as we always do to separate letters from numbers, and put a 5 in there and then another dash to indicate that the 1-methyl ethyl branch is located at carbon number 5. So it's carbon number 5 of the longest carbon chain is where you will find the 1-methyl ethyl branch located. So with that, we have 2 different ways that are both accurate ways of going about naming this organic molecule. What we're going to do in the next segment is we're going to go through a few additional example problems of naming organic molecules that will apply some of these other nuances and rules that we haven't had a chance to highlight here in this initial Quickstart guide. Also, on the worksheet that is available on the website, there is a whole page or more of different nomenclature problems to test your knowledge on this, so I highly recommend you check that out as well.